The purpose of this video is to review multiplying polynomials. So we'll start with multiplying monomials and work up to more complicated multiplication problems. So basically, starting with monomials, this is where everything comes off of. If we are just multiplying again, remember we can multiply in any order. So we can move this around. This 5x to the fourth is really 5 times x to the fourth. And this 3x to the squared is 3 times x squared. So we can multiply the 5 and the 3 together to get 15. We can multiply the x to the fourth times the x squared. Again, remember when properties of exponents says we can add these. It's basically x to the fourth is 4 x's. X squared is 2 x's. When I multiply this together, I have 6 x's. So that's x to the 6th power. That's kind of the main skill behind all of this we're working with. The other big skill involved comes down here with where we're talking about distributing. I have inside the parentheses. We all know, first we do inside the parentheses, but these are not like terms. So I cannot do anything inside here if I don't know what x is. So I have this 5x to the fourth outside. I'm going to distribute. I'm going to share it evenly. So I take 5x to the fourth times 3x squared. I already know what that is. That is my 15 x to the 6th power. Then I also take the 5x to the fourth times the minus 2x. So 5 times a negative 2 is a negative 10. X to the fourth times x is x to the third. We can always put a little 1 up on here and say 4 plus 1 is not 3. So let me correct that. 4 plus 1 is 5. Okay, now we do 5x to the fourth times the 1, and that's just going to be 5x to the fourth. Pretty much all of multiplying polynomials are based on these ideas of taking a monomial times a monomial. Is you take the number times the number, and then with the exponents, the variables, we add the exponents. Again, we have to have the same variable in order to do that. So where it just gets more complicated is when we start taking, besides a monomial, what happens if we multiply by a binomial or greater. So we'll come up to this one, a monomial or binomial times a binomial. Going to do it just this whole idea of distributing, but now instead of one thing to distribute, I have two things. So I'll go a different color on here. So I'll first distribute the 2x. So I'll take 2x times 3x is going to be 6x squared. I'm also going to take the 2x times the negative 5. Gives me a negative 10x. So I've distributed the 2x times both of those. Now I come along and I distribute the 7. Don't forget the negative when you distribute the 7. I take the 7 times the 3x. It's a negative 21x. I take the negative 7 times the negative 5. I get negative times the negative is positive, 35. I finally come along and I can say, yeah, I got some like terms here. The negative 10x and negative 21x are both x terms, so I can combine those together to give me negative 31x. The 6x squared doesn't have a like term, so it sticks out there. The 35 is on the back, and there's my answer. The basic idea comes down to we're just distributing. Everything in this parenthesis gets distributed to everything in that parenthesis. Now, another common way to keep track of that. The main thing that's going to mess you up when you do this is to forget one step along the way. The one way is to just draw out all these arcs to show I've done everything. I learned it. There's your smiley face. So you can see if it's smiling back at you, it works. Another way we often are doing this is we can set it up with, we call this the area model or the box. It's based on the Punnett square from biology when we're doing genetics with that. But we can set up, this is length times width, that's like the area of a rectangle. So I got the 2x minus 7, and I got the 3x and minus 5. And I set this up, box up, with the two sides, and then I just multiply each of these individual boxes. So when I take the 2x times 3x, I get 6x squared. I take the 2x times the negative 5, I get negative 10x. I take the negative 7 times the 3x, I get negative 21x. I take the negative 7 times the negative 5, I get the plus 35. And then I just add all of these pieces together. So I got 6x squared. That's the only x squared. But when I'm looking at the x's, both of these are x terms. So negative 21 and negative 10 is a negative 31x. And I'm left with this 35, which happens to be the same thing I got before. That works out really nice. Okay. So whether you use the distributive model or you use the box method, either way, it's just ways to make sure we get all parts taken care of. If I have a binomial times a binomial, I have two things times two things, I should get 4 answers. But I can combine some of them together, so I get down to a trinomial here. So what happens now? I got 3 of these. I work 2 at a time. I start off with the x plus 1 times 2x minus 3. And I'll multiply this one out. 2x squared minus 3x plus 2x minus 2 equals 2x squared minus x minus 2. So now my problem is down to 2x squared minus x minus 2 times 4x plus 5. Now when I want to multiply this together, I can just do my distributing again. I'm going to distribute this one because there's only 2 things to distribute. Instead of here I have 3. It doesn't really matter. I'll take 4x times 2x squared, and I'm going to get 8x to the third. 4x times a negative x is a negative 4x squared. 4x times a negative 2 is a negative 8x. Now I'm going to come and distribute my 5. So I'll go 5 times the 2x squared is going to give me 10x squared. You notice I line it up with the x squared. I'm lining up my like terms. 5 times the negative x is a negative 10, not a negative 10, negative 5x. 5 times the negative 2 is a negative 10. Now I add these down. 8x cubed minus, whoops, not minus. Think what I'm doing. Minus 4 plus 10 is a plus 6x squared. Negative 8 and a negative 5 is going to be a negative 13x and a minus 10. So if I have 3 or more things together, I just multiply 2 of them together, take the answer times the third. I want to look at doing another problem like this where I have a binomial times a trinomial. So for my last example here, I'll do just that. I'm going to do this one with the box method to show that as well. So this time I have a 2 by 3. So when I make my box, I'm going to have a 2 on this side, 3x, 9. And here I'll have my x squared, 5x minus 3. And then I just do again what I did. 3x times x squared, 3x squared. 3x times 5x, 15x. 3x times a negative 3 is a negative 9x. 9 times x squared, 9x squared. And I messed up already. X times x squared, this is x to the third. X times x, this is an x squared. Oh boy. 9 times 5 is 45. And we have an x. 9 times 3 is 27, and it's negative because we have that negative here. Now we pull out our answer. We have an x to the third. X squared, I got 2 of them here. So 15 plus 9, 24. X's, I again have 2 of them. So 45 minus 9 is 36. And I finally have a negative 27 on the end. Again, notice I'm again marking off all of these as I'm going by because since I don't have it ordered up like I did before. When you look at this one up here, I had them in order. I'm adding down. I'm making sure I get everything. But in this one, I don't have that. So I take advantage of the fact that I'm going to mark off the ones I do so I know I got everything. That's where you're going to mess up. So, let's get off here. Give you a chance to try some. If I can get this to work. Here we go. So, try these 4 problems. Pause the video. When you got them done, unpause the video and see if you match my answers. Okay, my answers. This one is 3x squared plus 5x minus 28. Second one is 2x to the third minus 13x squared plus 15x. Third one, I got 2x to the third minus 17x squared plus 19x plus 14. And the fourth one, I have x to the fourth plus 9x to the third minus 7x squared minus 45x plus 10.